Hello everybody, I'm Nick, and this video I'm going to take a look at LINQ's performance in C# and try to identify some of its shortcomings. By no means is this a video against LINQ. I use LINQ all the time. This is more about making you more aware on some surface level stuff around LINQ, because I think it's very easy to use, but it's one of those things that you never actually dig deeper into it. And even though you shouldn't just be anxious and be like, oh, I have to change all my LINQ code now after this video, it's more about keeping in mind that sometimes if you have a hot path, it might worth benchmarking and comparing whether you're actually going to use LINQ or not. I am actually planning to do a separate, more advanced video on the matter, talking more about closures and boxing and how predicates and memory allocations affect this matter in more detail. But treat this as a more introductory video on the matter. It's going to be a bit more simplified. If you like that type of content and you want to see more, make sure you subscribe and the notification bell to get alerted when I upload a new video. So let's go straight into the code. And what I have here is a good old benchmark .NET project where we are using bogus to generate a bunch of stuff. What we're generating in this case is drinks. We're generating 60,000 drinks. And the reasoning behind this generation is, let's imagine we have something that's processing 1,000 drinks per second, and we just get the sample for like 1 minute. Let's see what the performance of processing that in a minute would be. And what I have here is a LINQ method that is using a where clause to say whether the drink is alcoholic or not, and if it is alcoholic, it's getting a count on that drink. So what I want to do now is I want to run the benchmarks as they are, and like I said, we're using a seed in our randomizer, which means that no matter how many times we run this, the way that the data is created is deterministic, and it's always going to be the same just to get consistent results. So I'm going to go ahead and run this and get an initial benchmark for where we are performance wise with that filtering and counting operation using LINQ. And I'm only going to be focusing on the fluent side of things when it comes to LINQ. I'm not going to focus on the from C select that, this and that. Ultimately one is translated into the other. But I think that this is actually more prominent, so I'm going to focus on that. So what we have here is a mean execution time of 338 microseconds. And just to remember, 1 microsecond is 1,000th of a millisecond. So it's a fair amount of time. But okay, with that out of the way, let's take a look at what Rider is telling us to do. Okay, so Rider, because it wants the code to be more readable, it tells us to, hey, why don't you merge the where clause into the count, because count actually also accepts a predicate in a different overload. So what I'm going to do is I'm going to revert that change, and I'm going to create a new method here, and I'm going to call count directly with the predicate. Now, what do you, like, as I'm typing this, what do you think is going to happen performance wise? I'll tell you what I thought initially. I thought that performance would be the same, because I thought that internally what would happen would be the same thing. Well, let's see what the actual story is here. So I'm going to say count here, here you go, and you go here. I'm going to run that benchmark now and compare the two types of executions, and let's see where we are. And the results are back, and we're looking here that the original code without the predicate in count is actually more than twice as fast. So what happened here? Well, it turns out that just by making that change, we made the code slower, because in the where scenario, you're going to have the enumerable lazy loaded execution, and we're going to call the count method, which if we decompile, we'll try to optimize around the type of enumerable you have. Sorry for the need for this interjection here, but I was actually blind when I was initially looking at that method. It will actually identify that it is a list provider, and it will try to optimize by using a specific get count for that list. Sorry for that. Now back to the video. And the other code, the one with the predicate, actually has the predicate here, and then it doesn't check any type specific things. It just goes straight into a for each loop, and then it applies the predicate and it returns the count. So it's quite the different operation, and this is the essence of this video, really trying to understand that if you have a hot path in your application and you're using LINQ, I mean, first, the official Roslyn documentation actually says that if you have a hot path, don't use LINQ. But even if you're using it, try to benchmark around it if you really want those microseconds. And performance is contextual. Remember that always. So, for example, if you ask me, or if I ask you, is a request to a database that returns 1 kilobyte worth of document back, one entry back, being returned in 5 milliseconds slow? For me, 5 milliseconds on a database request for a single document is on the verge of being slow. For you, it might not be. And that applies in your code as well. Ultimately, performance is specific to what you're doing. There might be places where you want to do that because it's more readable and more easy to write and maintain as well. Or you might want to handcraft those for each loops. And this is what I'm actually going to do now. I'm going to create two methods here that use a for loop and a for each loop. And I'm going to add them into the benchmark and see how LINQ compares to those other two operations. So those two methods are now here. We have the for loop here and the for each loop here. By the way, do you know what's the difference between a for and a for each loop when it comes down to performance? If not, you might actually be surprised by those results. What I'm going to do is I'm going to add the two benchmarks. So one is the for loop and the other one will be the for each loop. And let's compare all four of them in a single test execution. And I'm going to run that and wait for it to complete. We have four of them, so they can take a minute or two for them to finish execution, but for you it will be like that. So results are back, and as we can see, we have some interesting results. The for loop is faster than the for each loop. We kinda, well, at least I kinda knew that because I have happened to stumble across it in the past. But what's very interesting is that the for loop and the LINQ where one are very close when it comes down to time. However, LINQ's biggest criticism isn't really the time, because at such small values, you know, you can spare those numbers. 1 millisecond saved in a minute is not really worth the effort of even talking about it. However, let's run the exact same benchmarks, but now add the Memory Diagnoser. And the Memory Diagnoser will actually get memory specific metrics as well out of those benchmarks, and we're gonna see where the memory stands around this whole situation. So let's give this a go and run it. Now the results are back, and let's take a look at those numbers. And as you can see, it is very interesting because the for loop is allocating no memory, the for each loop is allocating 1 byte of memory, which is both fine. But now the where clause, which is the faster one from the LINQ ones, is allocating almost twice the memory of the LINQ count. And this is, in my opinion, where the biggest caveat when you're using LINQ is. It's about the memory allocation, especially when you have a predicate that is referencing something from an outer context. This can really take a toll in both your memory and your time performance. And really, this is where the secret lies. Can you afford this memory allocation and potential performance hit, depending on which way you go about it, for in return to have better looking and more readable code? In some cases it can be a yes, in some cases it can be a no. But you have to understand that this does not come for free. I think the title of the video is LINQ actually slower? And yes, it is in almost every scenario. The most optimized LINQ that you will write will be faster than the most optimized handcrafted method you will write, but it's not gonna be more readable unless you extract it, and then that's a whole different discussion. Now, there are actually packages that provide an allocation free and also faster LINQ experience, but I don't want to recommend any of them because they come and go, and there is no point in recommending one if it is to be still in beta or abandoned. Even though those things don't really change over the time, you can make that search, Google search yourself. I don't need to recommend anything. However, what I want you to take away from this video is that if you have a hot path that really needs every last bit of performance sucked out of it, then it's a good idea to not use LINQ in that hot path and handcraft the method. Of course, benchmark the shit out of it to make sure you understand everything about how it performs. And also try to avoid using for each loops over collections that don't have struct enumerators. This is another thing that's coming straight from the Roslyn recommendation. One last thing I'm going to mention and raise is using things like toArray and toList. I'm going to add two methods that will filter for the non-alcoholic drinks and get their names. And we're going to run benchmarks to see how they look like, both speed but also performance-wise. So those samples are now in, and what I have here is a for loop. This is not actually for each, this is for loop. Sorry about that. And we're looping around the drinks, and we're checking if it's not alcoholic, and we add it into a list and we return that. And then we have the second one where it's a non-alcoholic drink. We are having a where and then a select to get the names, and then we're toListing to return the list, because both here and there we have a list. Remember, an enumerable is an interface representing an enumerable, but it could actually not be computed until you enumerate it. So keep that in mind. And I'm going to add those benchmarks here, two of them. And I'm going to say non-alcoholic. Let's start with the non-alcoholic for loop actually at the top, and then the non-alcoholic LINQ. And I'm going to just comment out the other methods. Why don't you like this? Oh yeah, because this is a list of strings. Sweet. And I'm going to import that, and I'm going to execute it, and hopefully in a second we're going to have some results on those two methods. So results are back, and as you can see, exactly what we expected. In both scenarios, performance is similar, but also the memory allocated is very, very similar. And that's important because if you just look at the code, we don't really create any list in both examples. We only visibly create one here, but obviously we're returning one here. And I'm erasing that because I want you to understand two things. First, the where and select will use a single enumerator to operate, so you won't actually do it twice, and that is reflected in the performance of the code. So LINQ will actually optimize for that for us. But also toList, anything that starts with a 2 when it comes down to extensions, for example, to hash set, to lookup, to list, to dictionary, to array, to anything 2 will actually create the object it's talking about and allocate that memory, while anything that starts with as enumerable, as parallel, as squareable will just cast it. So also keep that in mind when you're dealing with LINQ, because that's another thing I see wrong all the time. Now I'm showing this latter example because I want to tell you that there are things that the team is optimizing around, and there are actually proposals to optimize what is already there. And most of the time, if not always, those are not breaking changes. So the code that you write now that uses LINQ will be faster and allocate less memory as the time goes by and as the compiler becomes better. So ultimately what I'm trying to say here is, if now you have a hot path that needs every bit of performance sucked out of it, benchmark and see if you can remove what you have. If you can afford not spending time prematurely optimizing, which some people say is the root of all evil, then don't bother doing that. In the next video on the matter, we're actually gonna go dig way deeper and take a look into intermediate language code and talk about closures and more memory related matters. But on this very first video, I'd like to just stay here and focus on very high level things that everybody, every single one of us writing C# have actually been exposed to. That's all I had for this video. Thank you very much for watching. Special thanks to my Patreons for making this videos possible. If you want to support me as well, you're gonna find the link in the description down below. Leave a like if you liked this video, subscribe for more content like this, ring the bell as well, and I'll see you in the next video. Keep coding.